little data sheet, we're going to look for an equation for impulse. Looks like this: F times delta T is equal to M times delta T. I T in front of it. Hey, that's not the technical symbol for impulse, but that's the symbol I get for impulse. Again, it's not going to put it on the data sheet. Or I can use this form. Be careful here. Be careful. When you go to your right? All right, let's take a look at 458, 1 and 2. Any issues with either of those questions that we'd like to go over here? You know what? Nope. All right, 2 it is then. Dog team pulls a 400 kilo 4.2 back forward. Calculate the average net force on the dog sled, or sorry, the dog team exerts on this. Anything that stands out here in this question that maybe get backwards and forwards. Yeah, it's not a problem, but it's something that I have to be conscious. It's one of the to solve it now. That nice efficient tool that we learned a couple of days ago is called. Yeah, we're going to use impulse to solve this problem because what do you see in there that we use for that? 2 words. We have initial velocity, vi. So my data sheet, delta t is equal to m. That's also equal to delta p. Somebody help me with that. You had Like, we'll give you about 90 seconds to solve this problem. All right, let's have a look, everyone. It says, question says, in an automobile collision, the severity of injury to the driver can be reduced by an airbag. If the car is initially traveling at 100 kilometers per hour, the airbag stops the 62-kilogram driver in 90 ms. What's an ms? It's a prefix, right? And if you're not sure what that prefix means, top of the page, you're going to see all these different metric prefixes, and you're going to see that a milli is 10 to the minus 3. So the conversion factor is 1,000. It means to convert from milliseconds to seconds, you're going to divide by 1,000. We want to find the force. Okay, what are we going to do to solve this problem? One word. Boy, it's taking you a while. It's not like you're very impulsive or anything on this. What are we going to use to solve this problem here? Yep. Go ahead, Nathan. Yeah, okay, but what's the concept? What's the concept? Impulse, yeah. We're going to use impulse to solve the problem. Okay, we know our equation for impulse is delta P is equal to F times T is equal to M times delta V. Is there anything that jumps out at you here? Okay, Nathan, you just kind of started talking about one of them here. What is it? All right, we got to convert that to seconds, so let's circle that in red. Anything else? Yep. Kilometers per hour goes to meters per second. Guys, you wouldn't believe how often people make a mistake on a question like this simply because they forgot to convert units. Okay, this is especially bad, something like this. Doesn't seem like that crazy hard of a question, right? But there's 2 unit conversions to do. Here's what people will do. They'll do one of them, and then they'll forget to do the other one. Oh, I got my unit conversion done. Whew. Okay, now I can move forward and solve the question. Okay, keep reading. Okay, make sure everything is the way that it's supposed to be. Seconds and meters per second. All right, this is going to be VI. This is going to be mass. This is going to be time. We're looking for force. Anything else we have here? Read between the lines. Is there anything else? Yes, there is. There's one more given here. Lewis, what is it? Good. The final velocity is 0 because it stops. All right, we're going to use the 2 parts of the equation that appear on our data sheet again. So we're going to solve for force here, just like the last question we did almost. M times delta V divided by delta T. Mass is 62. Okay, delta V is 0 minus 27.777. Where did I get that from? 27.777. Where did I get that from? Yeah, I divided 100 by 3.6. And the time here is 90. Here's what I do for something like this, okay? I'm not a big fan of moving the decimal place over. Okay, what I often do is just say, look, a millisecond is 10 to the minus 3. 90 times 10 to the minus 3. Okay, that works just fine. What are the answer? What good to be there when we do that math? 1.9 times 10 to the 4. Okay. Good. How many people got that right? Good. Excellent. There's 2 things that can be explained by impulse. Pretty big, pretty important, pretty major things that can be explained by impulse. The first one is what I call a predetermined impulse. Let me explain what that means. Cars traveling down the road at 100 kilometers per hour. Got a certain amount of mass, got a certain velocity. What's going to eventually happen to that car? Yeah. It's going to stop, right? There's a ball traveling through the air. What's going to eventually happen to that ball? happened to it in between now and then? So what's the eventual impact? It's going to stop. Any object that will stop. Now, if it's got a certain amount of mass and it's got a certain amount of velocity, then that means it's got a certain amount of momentum. It's the destiny of the car. You know it's going to stop. You know the idea is that the impulse is predetermined. What you want to do typically is increase the stopping time. And the effect that that has is to decrease the force. So take a look at a number for a second here. If my impulse is 10, my time is 1, then that means my force is what? Got to be 10, right? 10 times 1 is 10. Well, if my impulse is 10, got to stay the same because it's predetermined, but my time goes up by a factor of 2, it doubles, then what's my force going to be? The impulse was predetermined. If you increase the stopping time, it decreases the force. You will get a question on your diploma exam almost certainly that asks you about this. It may ask you to explain why the goalie pads cause the or allow the goalie to stop the puck that's moving at 100 miles an hour and not hurt. Right? It may be why an airbag keeps a driver from being as seriously hurt. It may be why, to explain why the crumple zone in the car keeps you from being seriously hurt. It may be to explain why you bend your legs when you jump off your desk. Okay? It doesn't matter what the context of it is. If the question asks you about anything that cushions an impact, the answer is impulse is the same, time goes up, force goes down. Does that make sense? Now, you can imagine, although this doesn't occur all that often, you can imagine possibly the opposite effect. Is there ever a time when you might want to decrease the stopping time? Make the stopping time smaller? What effect would that have? It would give you more force. Well, if you want to break something, then you might want more force. If you want to break something, then you might want to decrease the stopping time. Does that make sense? Usually it goes the other way around though, right? If you're trying to cushion an impact, you're certainly trying to increase the stopping time to decrease the force. Now, there are other things involved in impact safety things as well, like say a hockey helmet. Right? You got cushioning inside a hockey helmet. What does that cushioning do? It increases the stopping time of your head. It decreases the force on your head. But the entire helmet is also designed to spread the force all over your head, not just in one spot. So it spreads it over a bigger time, but it also spreads it over a bigger area. So that's a pressure thing. Right? Okay, that's not related to impulse at all. Certainly impulse is a factor. Increased stopping time, decrease force, but there's also, as I say, sometimes some other factors as well. Right, Alicia? The other situation that can be explained by impulse is when we have the exact opposite situation. I don't even know if this is a word. I don't think it is, but I'm going to make one up. It's when we have a non-predetermined impulse. I don't think it's legal to even have two hyphens in the same word, is it? Maybe you could call it an undetermined impulse, but I like this better. Non-predetermined impulse. That generally occurs when an object is starting. Right? You follow through, right? You follow through. And if you're a golfer, don't take my swing as being good. But we know you follow through, right? We know you follow through. Why do you follow through? Because when you follow through, it increases the time of contact between your club and the ball. You hit it twice as hard, good. It's going to give it twice the impulse. You double the time of contact, you're going to give it twice the impulse. Ideally, you hit it hard and increase the time of contact, and then you're going to really increase the impulse and make the ball go even further.